So I am pleased to introduce our next speaker team, which is Erin Reilly and Scott Lerberg from Chesapeake Bay, Virginia, NER.
Hi, everybody. So Scott isn't going to talk because we figured in 8 minutes it would be easier for just one of us to talk. But so we were looking at high tidal datums and the water levels at our marshes in Virginia. And so just to kind of start, we need tidal datums and water levels for a lot of things. We have a lot of research questions about them. They're used for restoration design. They're used for infrastructure design, property boundaries, especially depending on your state, if you're a mean high water state or a mean low water state. It's also used for weather and risk prediction and also navigation purposes. But not everywhere has NOAA tidal stations really close by where they calculate datums. Um, and NOAA calculates tidal datums on the 19-year epochs. And so with accelerating sea level rise and kind of the location of um, all the NOAA stations, all the sites that you're actually looking at and concerned about when you're thinking about restoration and things like that, the tidal datum that is available for you might not actually be appropriate. So we were looking at our sites with kind of the thought of, can we calculate updated tidal datums from a variety of data sources that are available at the near sites, because we have a lot more data than other people, and compare that with habitat maps that we have, with kind of the goal of looking at identifying stress sections of the marsh, calculating site-specific tidal datums, and then incorporating this back into our restoration plans. So we looked at 5 different water level sources. The first one is the regular NOAA tidal epoch. This is what NOAA says is our tidal datum in the area. We then took the NOAA data from that station and just calculated it from 2013 to 2023. We took the V datum. So this is a tool that NOAA's put out that helps for areas where you don't have tidal stations. It models it out for that area. We also took our swamp stations and converted the depths into water levels. And then we have some radar gauges out at our stations as well. And so we took all of these, calculated our mean low water, mean low water, mean high water, et cetera, to get our new tidal datums and compare. So this is just a quick look at the Chesapeake Bay in Virginia reserves. We're a component reserve, so we have 4 components along a salinity gradient of the York River. And you can see this Yorktown Coast Guard Training Center down here. This is our closest NOAA co-op station. So it's pretty good and pretty close to our Catlet Islands and Goodwin Island stations, but it's a little bit further away from the other 2. You can also see on here, we have radar stations at the furthest upriver 3 sites. It kept getting struck by lightning at our most downriver site. And then one of our sites over here at Catlet Islands doesn't have a swamp station because there was a further upriver swamp station established before Catlet Islands became part of the reserve. So we decided to keep that swamp station, and then and that kind of serves as the station for Catlet. So we've got a little bit in terms of variety of the different data sources. But this is kind of the updated look of, for one of our sites, what the current tidal datums are. So that's this column, the V datum, tidal datums. And then if you take the last 10 years of data from the Coast Guard station, and then our swamp data and our radar data. So this is for Taskiness Creek, which is our 3rd upriver site. And so you can see that the mean high water levels and mean low water levels are a lot different than what both V datum predicts, as well as like what the current epoch is. And so we've taken that and put this onto, this is a contour map from the Kona DEM. And the 2 contours in green are the current tidal datums, and the yellow and orange are the from the NOAA station, the updated tidal datum. So this is just basically thinking more like property values and infrastructure, property lines and infrastructure values. You can see that it can make a big change over this 20-year period with the current rate of sea level rise in our area. So we've used this and found some of the sites where you'll see a big change in the mean high water level. And then we compared this to our habitat datums. And so on this map, each of the different types of habitats, the darker color is a lower elevation. Um, and so you don't need to read all of this, but basically we took that then and identified it, outlined in black, the areas that have plants that are going to be more stressed out because they're not in the tidal datum that they want to live in. And this has led us to some interesting site explorations where we think we're trying to plan some thin layer projects or other restoration where we've identified some of the places that aren't necessarily on our vegetation transects or things like that at our sites where we don't always go frequently. So one of the things also I just want to say, if you want to do this, is to check your results. So it came up and we were very curious about our one of the living shorelines at the site performed really poorly. And we were like, well, we've just done this restoration. Did we do it wrong? Did we not put it in at the right elevation? And we went back to look at the DEM, and it turns out that our DEM, which the one that we use, the metadata has 1859 to 2015. The DEM is before the living shoreline was installed. So you just need to make sure that kind of you're keeping on top of like what data you're actually using and the timeframes there. And so moving forward, we're working on trying to expand the datum updates to all of our tidal components. It's been kind of a slog trying to get through all of the data and matching up when we change out tubes and what the conversion to NAVD88 is and things like that. So we're expanding it to the rest of our components. We want to try to look at a time frame sensitivity analysis. So is it when we used the NOAA data, we used the last 10 years because we wanted a longer time period, but for restoration, you don't maybe have 10 years worth of data. If we throw it out for a year, is that enough? We're also working on trying to get better DEMs. We're working with a NOAA GIS person who is helping us try to figure out how to get better DEMs and optimize the DEMs for a site. We're also working with the state to determine how the 2026, I say this in quotes, datum updates is going to actually impact the regulations in Virginia. We have in our regulations tidal datums listed, and so that could cause a lot of consternation. And then we're also part of the Drone the Near program, so we're hoping to update our habitat maps so we can kind of link up the timeframes a little bit better and then use that to incorporate the into our restoration plans any of these vulnerable areas that we identify.
Perfect. Thank you. You came in without me having to even ring the bell. There's no question in the chat, but can you just review again sort of how you updated your datums? Was that with your own data or just by using the most recent time period?
So we used our own data. Our radar data is our own data, and the swamp data we took our own data, but it's also available from CDMO. And then the NOAA Coast Guard station data, which is the co-op station that's closest to us, we downloaded that to use to calculate the tidal DEMs. And there's an R package that we use. It's called Vuln Toolkit. And that's the package that we use to calculate the datums.
So cool. Anyone else have a question? You're welcome to unmute yourself if anyone has a quick question. All right, then put it in the chat later if something occurs to you.